2012 A-Level Pure Maths Part 2 question number 11. This consists totally 150 marks, giving the remainder theorem, factor theorem part in question B and the quadratic part in question section A. Okay, let's carry on with the discussion. Okay, now they are telling you question number 11 part A. Fx equals x squared plus 2kx plus k plus 2, where k is a real constant. Roman 1, they are telling that k is a real constant itself. K is a real number. Express fx in the form x minus a whole thing squared plus b, where a and b are constants to be determined in terms of k. Okay, when they are telling something like this, you have to, basically what you have to do is express fx in this format, x minus a whole thing squared plus b. Now you can see this particular format is completed square format. This is completed square format. So what you have to do is take this fx. What is fx? Fx is x squared plus 2kx plus k plus 2 and complete the square here. So if you complete the square, you get x plus k, x plus half of this k whole thing squared minus k squared plus k plus 2. So now this is in the format of x minus a whole thing squared plus b. And very importantly, they are telling constants to be determined. When they are telling constants to be determined, they expect you to find the values of a and b, and that also in terms of k. So what is the value of a? A means minus k, because minus a is k, no? So a is minus k. What about b? B is minus k squared plus k plus 2. If you want to put the plus in front, you can write it like this also, no problem. The order doesn't really matter. They will give you marks for either. Both of them are correct. Okay, then find the turning point of fx without using calculus. Very important. Okay, first of all, let's find the turning point. You know that in a completed square format, if you have this format, the turning point of this will always be the negative of this. Negative of minus a is a and b. So turning point will be what? A comma b. What is a here? Minus k. So turning point is minus k comma b. That is 2 plus k minus k square. This is the turning point. Easy. We didn't use anything other than the general knowledge that we already have. Turning point done. And show that this point is a minimum point. This is very easy. All you have to do is, if you analyze fx equals x squared plus 2kx plus k plus 2, the leading coefficient here is what? 1, right? The leading coefficient equals 1, which is greater than 0. Therefore the graph is a minimum graph, or else you can also write the function is a minimum function, which means a turning point is a minimum point. Okay, so the graph will look like this, with this being the turning point. If by any chance a is negative, the graph will look the other way around. Okay, that part is also done. Then find the minimum value of fx in terms of k. You all know that when you have a function, the minimum value will always be the y coordinate of the turning point. Minimum or maximum. Minimum value is always y coordinate of the turning point. So in this case, fx, the minimum point is what? This part here. That will be 2 plus k minus k square. That part is also done very easily. Next, hence. Now they are using the word hence. Be very careful. This is done, this part is done, this part is done. Hence show that curve y equals fx, they have given you three conditions. Hence show that curve y equals fx, A lies entirely above the x-axis if here the condition, touches the x-axis if condition, cuts the x-axis in two distinct points condition. Okay, let's analyze one by one. Now if you consider this graph here, now the first condition is y equals fx, alpha is telling you lies entirely above the x-axis. Now this actually, if you sketch the graph, now I will not sketch the y-axis. If you consider the x-axis like this, okay, the graph is like this, okay, lies entirely above the x-axis. Now, if you consider the graph is entirely above the x-axis, this point here is the minimum point, which means this minimum point also lies above the x-axis. Whatever that lies above the x-axis, now here, if you consider below the x-axis, y is negative. Above the x-axis, y is positive. So when they say the curve lies above the x-axis, this means minimum point also lies above the x-axis. You can say fx min lies above x-axis. What does this supposed to mean? Fx min is positive. Fx min is positive. Okay, now if you consider what is fx min, you already know the value of fx min. We got that 2 plus k minus k squared. So you can say 2 plus k minus k squared is positive. So k squared minus k minus 2 is negative. Multiply that by minus 1. Now you can open brackets, k times k, 2 times 1. Here this is minus, here this is plus. K squared minus 2k, this will give you the value. So this means limiting value k equals 2, the limiting value k equals minus 1. Sketch the number line. K equals minus 1 is here, k equals 2 is here. Now get a number between minus 1 and 2, I will get 0. If you substitute 0 equals k, so 0 minus 2 it's negative. 0 plus 1 it's positive. So positive times negative it's negative, which means this and this ideally should be positive. If you want, you can put the number, substitute and find the value as well. Now, what does this supposed to mean? They are asking you whether the show the values of k where the function is negative. You can see function is negative between minus 1 and 2. So you can say k is between minus 1 and 2. Okay. So we have proved the first one. Is this not what they have been asking? Lies entirely above the x-axis if k is between minus 1 and 2. So it's best if you can finalize the answer, write a sentence there. Therefore, the curve or parabola or function y equals fx, y equals fx lies entirely above the x-axis if k is between these two values. Finalized. Okay, that is part alpha. Now they are asking beta, touch the x-axis at this point. Beta touches the x-axis if they have given you k equals minus 1 or k equals 2. Y equals fx touches the x-axis. Now, when you look at the graph, it will look like this. This is the x-axis, and this point here will touch it. When they say the curve is touching the x-axis, actually, if you are saying only one point is touching, only the minimum point can be touched. So this is the minimum point, or else the turning point. So when the graph is touching the x-axis, this means that the minimum point equals 0. Only when the minimum point equals 0, it can touch. Okay, when the minimum point is 0, you know that 2 plus k minus k squared equals 0. Multiply this by minus, you will get k squared minus k minus 2 equals 0. You can factorize, you already know this factorization. 2 times 1 minus and plus. K minus 2 equals 0, k equals 2, k plus 1 equals 0, k equals minus 1. So you can say that y equals fx touches the x-axis when, if you can say, if k equals minus 1 or k equals 2. That part is also done. Then gamma. In gamma, they are telling cut the x-axis in two distinct points. Cut the x-axis in two distinct points. Okay, what do you mean by this? If you consider the x-axis will look like this. X-axis, cutting the axis means like this, no? Let's say y-axis goes like this. You don't need the y-axis actually. So 2 points cut. So the minimum point will be like this. This point here will be the minimum point. So you can say that fx minimum is negative. Below this is negative, no? So fx minimum is negative. You can say case 2 plus k minus k squared is negative. This is the inverse of alpha. So k squared minus k minus 2 is positive. 2 brackets k minus 2 k plus 1, obvious. Here you should take the limiting value minus 1 and 2, already explained in the alpha part. Then you have to substitute values. Here you will get negative, here you will get positive, here you will get positive. This is already explained in the alpha part. Refer to that again. Okay. According to this, you can see when this function is positive, when it is lesser than minus 1, when it is greater than 2. When it is lesser than minus 1, when it is greater than 2. So you can say when it is lesser than minus 1, k like this, union k is greater than 2. So you can say that y equals fx cuts the x-axis in two distinct points if k is lesser than minus 1 or union means or k is greater than 2. Okay, that part is proved. Next, Roman 2. Prove that the straight line y equals mx intersects the curve y equals fx in two real and distinct points for all values of all real values and finite values of m. Okay, let's read the question again. Prove that the straight line y equals mx intersects the curve y equals fx in two real and distinct points for all real and finite values of m if and only if k is lesser than minus 2. Okay. Now this is a situation like this. Now when you say a straight line is intersecting a curve, there are three different scenarios. You can have a curve like this and a straight line like this, like this. This won't intersect. Or else you can have a tangent like this, it will touch at one point. Or else you can have it like this, where this will cut like this, two distinct points. Out of this, they are telling not option 1, not option 2, option 3. Not this, not this. They are talking about this option 3. So now you have equation y equals mx, basically the line, and y equals fx. Do we have a, yes, we have fx, y equals fx. You can say this is actually x squared plus 2kx plus k plus 2. All right. Now you have to see, now if you are taking option 3, the straight line is intersecting the curve, which means both the y values should be same here and here. So you can say mx, this y value is equals to fx, like this. And now you have a new equation. Take this mx to this side, you will have x squared plus 2k minus m x plus k plus 2 equals 0. Now if you have two distinct points here, the delta of this particular equation, should be greater than 0 if it is two distinct points. So you can say delta of this equation is positive. So what is the delta of this equation? I will do in the next page. You have x squared plus 2k minus m x plus k plus 2 equals 0. The delta value is positive, which means what is the delta value? Here delta equals v squared. So 2k minus m squared minus 4, 1 and k plus 2. When delta value is positive, you can say that this value is positive. Whole thing squared minus 4 times k plus 2 is what? Positive. Now I'm going to take this 4k plus 2 to this side. So 2k minus m whole thing squared is greater than 4 times k plus 2. 2k minus m, if I bring 4 down, 2 whole thing squared, same thing, is greater than, like this. Now this will always be squared, which means always be positive. This will be always positive. The least value this can be is what? 0. The least value this can be is 0. Suppose this becomes 0. If this is 0, for this to become lesser than this, if this becomes 0, the least way, if this becomes 0, this k plus 2 to become lesser than 0, then k plus 2 should definitely become minus. Correctness. So because if you have 0, 0 is greater than any negative number. Okay, so if this is 0, this should definitely be negative, which means k plus 2 should be negative, k should be lesser than minus 2. Thus we have proved this part. Okay, then the first part is done. Now we have the next main question, remainder theorem and factor theorem question, part B. If you consider part B, let gx equals x to the power 4 plus 4x to the power 3 plus 7x to the power 2 plus 6x plus 2. Using remainder theorem, repeatedly show that x plus 1 is factor of gx. Okay, by remainder theorem, now factor theorem is a derivation of remainder theorem, so I will use remainder theorem. Remainder of gx when divided by x plus 1 is g minus 1. So what is g minus 1? 1, do step by step. Minus 1 to the power 4 plus 4 times minus 1 to the power 3 plus 7 times minus 1 to the power 2 plus 6 times minus 1 plus 2. 1 minus 4 plus 7 minus 6 plus 2. Here you will get 7, 8, 9, 10 minus 10 0. So minus 1 is 0, therefore x plus 1 is a factor, since remainder is 0. So now you can use long division. You can use long division, x to the power 4. I prefer to use the long division. You can use this the division algorithm and solve the same thing. 7x to the power 2 plus 6x plus 2. You divide this whole thing by x plus 1. X to the power 3, here x to the power 4 plus x to the power 3. 4 minus 1 is 3x to the power 3 plus 7, 6 and 2. 3x to the power 2. 7 minus 3 is 4. Here you will get 4x 4x squared plus 4x. Here you will have 2x plus 2. Here you will have plus 2. Okay. So now you can say gx equals x plus 1 times x cube plus 3x squared plus 4x plus 2. Let's name this as hx. Okay. Let hx. Okay. Then by remainder theorem, you can say h minus 1 is the remainder upon divided by x plus 1. So h minus 1 is minus 1 to the power 3 plus 3 minus 1 to the power 2 plus 4 minus 1 plus 2. So here minus 1 plus 3 minus 4 plus 2. 3 plus 2, 4 plus 1, 5 minus 5 is 0. H minus 1 equals 0. Okay, if h minus 1 is 0, you can say that x plus 1 is a factor of gx, sorry, not gx, hx, because, don't write because like this, remainder is 0, or else write the word since remainder is 0. Now what you can say by this, you can say hx is x plus 1 times, let's say ix, possible. Okay, ix you can write like this in this form. Now you can write gx as x plus 1 hx and hx as x plus 1 ix, which means you can write gx as x plus 1, wherever you have hx you put this x plus 1 ix, substitute 1 2, substitute 2 in 1. So gx will be x plus 1 squared ix. Okay, x plus 1 squared ix. You have to define ix. Here ix is the quotient when hx is divided by x plus 1. Okay, so therefore what you can derive out of this, what is the question they are asking, x plus 1 whole thing squared, therefore x plus 1 whole thing squared is a factor of gx. Okay, express gx in the form of this, gx in the form of this, basically they are asking you to find ix. Okay, now if you consider hx, long divide hx. Okay, so what is hx? You will have x to the power 3 plus 3x to the power 2, 4x plus 2. You divide by x plus 1. Here you will have x squared. So here x to the power 3 plus x to the power 2. This and this cancel off. Here this will become 2x squared plus 4x plus 2. Here you have 2x squared plus 2x. This and this cancel off. This becomes 2x plus 2. Here you will have 2. So 2x plus 2. So basically you have ix equals what? X squared plus 2x plus 2. So now you can write gx in the format of x plus 1 whole thing squared. This one, yeah, this one you are writing. X squared plus 2x plus 2. What have they told you to write gx in the form x minus a whole thing squared, x squared plus bx plus c. A, B, C are constants to be determined. A equals minus 1, B equals 2, and C equals 2. These are the values we need. That also done. Then deduce that gx is positive for all real values of x. Gx is positive for all real values of x. Now gx is x plus 1 whole thing squared, x squared plus 2x plus 2. Now, in order for gx to be positive, this should be positive, this should be positive, or this should be negative, this should be negative. Either it's positive multiplied by positive or negative multiplied by negative. But we know that x plus 1 squared, since this is a square, this part is always what? Positive. Which means for gx to be positive, this part must be positive. All we have to do is prove that this is positive, then we get the answer. We have to prove it. How to do this? X squared plus 2x plus 2. Consider this. Okay. This is a minimum. This is a minimum function. Why is it a minimum function? Because the first value here is 1, which is greater than 0. So this is a minimum function. So the graph will look like this. If you want to say this whole thing is positive, which means the graph will lie above the x-axis. The graph will lie above the x-axis. This means there will be no roots. What do you mean by roots? The definition of root is where the graph touches the x-axis. If this is positive, the graph will not touch the x-axis, which means there will be no roots. Consider delta. What is delta here? Delta equals b squared 4 minus 4 ac. Delta is 4 minus 8. Delta is minus 8. So our prediction is correct. Delta is negative. Therefore, no roots or no real roots. Real roots for x squared plus 2x plus 2, which means x squared plus 2x plus 2, a minimum graph will not touch x-axis. It will not touch x-axis, which means always lies above x-axis, which means the function is always positive. Therefore x squared plus 2x plus 2 is always positive for any real number. X squared plus 2x plus 2 is always positive. It's not even equals to 0. Okay, now that x plus 1 squared is always positive for any real number, okay, x squared plus 2x plus 2 is positive for any real number, you can say that gx is greater or equal to 0. Since you're multiplying these two, the equal sign will come for any real number. Okay, so that finishes our question 2012 A level part 2 paper 2 question number 11, 150 marks question. Finished and finished.